So, the aim of today's experiment is to analyze and design an inverting and non-inverting mode amplifier using operation amplifier. And we also call it opamp, operation amplifier. So, since you have not studied this device in your classes yet, theory classes yet, just think it as a magic box, which can be used for various operations. That is why it is called operation amplifier. Operations like adder, subtractor, and amplifier. Amplification. So, in today's experiment, we will see this application of this magic box. That is, how can we amplify our input signal, and why we are giving two modes, inverting mode and non-inverting mode. Inverting mode means if the polarity in inverting mode, the magic box, this magic box, which is an operation amplifier, not only amplifies your input signal, but also it changes the polarity. So if you provide an input signal which is drawn by blue, you will get something like this, that there will be some gain and the polarity will also be reversed. So that is why this is called inverting mode amplifier. So when we use this operation amplifier in this mode, then it is called inverting mode operation amplifier. And if you just want to simply amplify, we are not interested at all in inverting the polarity of the input signal, then we will use it in non-inverting mode. So that is then it is called non-inverting mode operation amplifier. So this is non-inverting mode of this operation of this opamp, and this is inverting mode of this opamp. So how this operation amplifier looks like when you go to a physical lab, and when you see, this will look like a 7-4 an IC, integrated circuit. So it is like a plastic cover, and there are many pins. There are 8 pins here. So it will look like this. And we generally call it as a 7-4. Not generally, the most common form of operation amplifier is 741. Just remember it, 741 IC, integrated circuit. So this is an IC whose name is 741, and it consists of 8 pins, and each pins have some different role. So we use first pin and the 5th pin. So you can remember it like this, these diagonal pins, first pin and 5th pins. These are used for offset null. It means if there is some voltage available without providing the input, we fix it, we tweak it so that the output is 0. We provide offset. So in our lab, in our experiment, we will not use these 2 pins. So just for the sake of knowledge, I'm just saying that it is an offset null. It will provide you offset null. And the second pin is used for minus in. Means we provide input to the second pin when we want to use this opamp as an inverting mode of amplifier. And the third pin is used also for input when we use it for the non-inverting mode of amplification. There are 2 supply voltages. As you all know that if you want something like your input is X volt and the output is Y volt, and Y is greater than X if you want a gain. So by the law of conservation of energy, you should know that you should also provide some supply voltage. Then only you can get some gain, right? So supply voltage is provided at 4th and 7th pin. 4th pin is used, we provide supply voltage in the form of minus VCC, and it is plus VCC. So it is supply voltage. So just remember it. And the value of the supply voltage, I will tell you later. It depends on the various variants of the ICs.
Hello.
हाँ जी बोलिए. Okay.
Excuse me, sir.
Yes, please go
So
ahead.
can you explain that offset null again?
Yeah, offset null is like you want to tweak your operation amplifier. Like it is if there is something present in your IC without providing the input, then you can tweak so that it is zero, right? When no input, the output should be zero, right? But due to
Sir,
some internal things, there is some voltage, so we can tweak it. But we will not use it here, so we are not giving much emphasis on this offset null.
sir,
Okay?
you just said that it depends on the various variants of.
No, the value of the VCC, supply voltage. At what should be the maximum value of supply voltage? Like, see, you have a IC, right? So there are various variants of ICs. If you use the material, according to the material, you can provide supply, right?
Okay, sir.
So these are the various variants which will, if the time permits and in future you go to our lab, you will see these are the various variants of ICs which are available in our lab. LM741, LM741A, LM741C. Okay, so these different variants of ICs has different supply voltage. You can provide maximum supply voltage at different values to these ICs. It depends on the material used. Okay.
So that non-inverting mode will be used with 7.
No, these supply voltages will be always given for both the modes. For both the modes, you have to provide the supply voltage.
Okay, sir.
Okay. Just hang on, and you will, when we further proceed, you will know more. So, and the output, if we want to measure the output, we have to put our probe at pin number 6. So, you can remember it just in front of the plus in pin. In front of the plus in pin, you have an output voltage. Now we have covered the pin configuration of this 741 IC. So physically, it will look like this, and it has 8 pins, and each pin has a different role, which you have seen here. Correct?
Sir,
Now, bolo.
Sir, tell
sir,
us
could you
about
explain the first one again, NC1 or whatever it is?
Please come again. Can you just?
Could you explain this NC or beside that supply voltage?
Okay, yeah, this is not connected. We don't use it. It is called not connected.
Okay.
So now you know all the roles, and we provide numbering like this. Okay, we go in this fashion.
So
One, two,
what is the use of that 8th pin?
8 pin is not connected. We don't use it.
And
Okay.
actually, why is it present?
Yeah, it is presented. I mean, in future we can use for some applications, but here we don't use it for this lab. Okay, so we call it not connected.
so
So, bolo.
so we are taking output from only one pin, like V not.
Yeah, we not. Correct.
So sir, how can we take output from only one?
No, ground is always there, right?
Okay, sir.
Yeah, ground is there. It is with respect to ground.
Okay, sir.
Good question. So now, as I told you, this opamp can be used in two modes, like inverting mode and non-inverting mode. So what is the gain and how will we use this operation amplifier if we want to use it in inverting mode? So in inverting mode, because it is two input, right, and one output like this. So we represent it like this in triangular form. This is a standard notation just to analyze the operation amplifier. You will know more in theory classes. So just in second pin, this is the third pin, this is sixth pin, this is fourth pin, and this is seventh pin. If you remember, second pin is non for use for inverting mode, and this is for plus when we use it for non-inverting mode. And this is fourth and seventh, which is used for supply voltages, and six is used for output voltage. And we use two resistors, R1 and R2, in this fashion. The R2 is a feedback resistor. Why we are calling it as a feedback resistor? Because it adds the input with the output, right? Just you will learn more in the theory classes, just in order to remember that inverting mode amplifier, the gain is minus R2 by R1, where R2 is your feedback register and where R1 is your input register. And why this minus sign we are using? Anybody? Can anybody
Because
guess?
it's inverting.
Very good. Great. Because it's inverting the polarity of your input signal. So whatever is the polarity of the input signal, the output will be just reversed. That is why we are using a minus sign here. And if somebody asks what is the magnitude by which we are having the gain or we are amplifying our signal, then it is R2 by R1. Okay. So if somebody asks you, I want a gain of 2, whatever input I provide, I just want to double that. So what should be the value of our R2 and R1? And we also
R2
want
should be 2R1.
excuse me, we also want to invert. So if your aim is, if somebody gives you a task that invert and amplify your input signal, and if the amplitude or the magnitude is X and it is Y, so the gain is minus Y by X, right?
Yes.
So R2 by R1, if you fix your R1 to 1, if you fix your R1 by 1 kilo ohm, what should be your value of R2 in order to get the gain of Y by X? Y by X, right?
2 kilo.
So if you want the gain of 2, you have to just fix your R1 by 1 kilo. You can change your R2 to 2. Then if you want to a gain of 3, it's not K, it's only 2. Then if you fix your R1 by 1K, you have to just change your R2 to 3K, correct?
Yes, sir.
So that is how you will get various gains by using this. So this is the inverting mode of amplifier. And remember what is the gain? Feedback register divided by the input register. R2 by R. Just remember it. How we get that, you will learn in the theory classes. Okay. So what we have learned till now, that we are using a magic box in order to get two operations, that is inverting and non-inverting our input signal and also getting us some gain. And when we use it for inverting mode, the picture will be like this, and the gain, the value of the gain will be R2 by R1. Okay, and we fix the value of R1 and we change the value of R2 according to the gain. Correct?
Done, sir.
Great. So now we will use it for the non-inverting mode of operation. Non-inverting mode, yani we want just an amplification. Whatever input we provide, we just want to amplify it. So when we use this operation amplifier or this magic box in this mode of operation, this mode, then our picture will look like this. We provide our input to third pin, okay, and the rest will be similar. And the output is evaluated here. And the gain, the thing, we get a factor which is 1. So the gain is 1 plus R2 by R. Just remember this. So for the non-inverting amplifier, in non-inverting mode, when we use this opamp in non-inverting mode, our gain is 1 plus R2 by R. And why there is no minus sign?
Non-inverting.
Great. Because we are using it non-inverting. So the gain of non-inverting mode amplifier is 1 plus R2 by R1. So just remember this factor 1. Okay. I remember it like that. When we use for inverting, it is R2 by R1. And when we use inverting, non-inverting, because we are just putting N, so we'll put 1 here. Okay? Just remember it like this. So 1 plus R2 by R1. This is the gain of our non-inverting mode opamp. So now if we want our gain of 2, we want to double our input signal. If somebody gives you a task, just double my input signal.